Welcome to Example 1.1. This is a great little example, well worth your time working through, because it's going to help you understand the difference between the null and the alternate hypotheses, and it's going to get us going on the discussion as to what exactly is the direction of extreme. Okay, so let's take a look at the setting for this here example. What we've got are three different settings that they want us to state what the null and the alternate hypotheses are, and then decide, is it a one-sided to the right, one-sided to the left, or a two-sided alternate hypothesis. So notice the second question's emphasis on the alternate hypothesis. As a matter of fact, that should be our emphasis on the first question also. Looking to figure out what the null and the alternate hypotheses is really mostly going to be keyed upon what is the alternate hypothesis. Now the alternate hypothesis, that's the research hypothesis. That's a real good alternate name for the alternate hypothesis, if you'll pardon the pun, okay? So where are you going to find the alternate here? Well, they're talking about a study, so a study must be the researchers. And what it says is that the study suggests that taking aspirin can cut your risk of colon cancer, okay? So the null hypothesis basically says pretty much the opposite of whatever the alternate says. In this case, it would say, well, that taking aspirin doesn't reduce your risk of colon cancer, okay? So let's go ahead and type that up here. So the null hypothesis is going to say taking aspirin does not reduce your risk of colon cancer. Risk of colon cancer. Okay. All right, well, what about the alternate? What is it going to say? Well, it says that taking aspirin does reduce your risk of colon cancer. Okay, all right, so that takes care of stating the null and the alternate hypotheses. All right, what about deciding the direction of extreme here? Which way does the direction of extreme go? Well, how are you going to figure that out? Well, in this case, what we're saying is that what? The more common stuff in the alternate hypotheses is going to be smaller, or to which direction? To the left of the null, okay? In other words, the risk of colon cancer in the null, we can think about it this way, the risk of the colon cancer in the null, I got a pen here for you, is larger than the risk of the colon cancer in the alternate. So if you think about that in terms of a number line, the risk according to the null, right, if it was right here, okay, it's going to be larger than the risk presented by the alternate, okay? Well, so if the risk presented by the alternate is smaller, it's one-sided to the left. In other words, you're going that way with it, aren't you? Okay? So, get the pen here, the typer, okay? So this test is one-sided to the left, okay? All right, hopefully that's making a little more sense now. So let's go take a look at average lifespan problem 2. Suppose you work for a company that produces cooking pots with an average lifespan of 7 years. So to gain a competitive advantage, you suggest using a new material that claims to extend the life of the pots. You want to test the hypothesis that the average lifespan of the cooking pots made with this new material increases, okay? So you want to test, in other words, so you are, in this case, the researcher, and what's going on here is that the lifespan of the pots increases. Those are some key words that we're looking at, all right? So the alternate hypothesis, or the research hypothesis, is that the lifespan of the pots has increased, okay? So let's go ahead and see if we can get the null and the alternate written here, okay? So the null hypothesis is the lifespan of the pots is unchanged, okay? Put an A in there. Is unchanged or is the same, all right? And then what about the alternate. What is the alternate saying? Well, the alternate saying is, let me back up here just a little bit. Get this here. Paragraph start on the right spot there. It'll work right there. Okay. Is that the lifespan of the pots has increased. Okay. So in other words, that the lifespan has gotten longer. All right, now let's think about what we just did in the previous example to help us out figuring out which way the direction of extreme goes here. Okay. So let's draw ourselves a little number line here. And the lifespan of the pots, that's given by the null, the current lifespan. So let's say the current lifespan is right here on the number line. So it's just the null, some values right here in the number line, and we'll say that's where it's at. Now, what's the lifespan of the new pots according to the alternate? Well, the lifespan of the new pots according to the alternate is over here to the right of the null, isn't it? Okay, so it's over that way. So what that tells me is that this is going to be a one-sided test to the right. So this is one-sided to the right. Okay. Hopefully you're starting to get the hang of here how we decide which direction we're going with our direction of extreme. All right. Okay, one more of these. Polling results. Based on a previous poll, the percentage of people who say they plan to vote for a Democratic candidate was 50%. The presidential candidates will have daily televised commercials during the week before the election and a final political debate. One hypothesis we might want to test is that the percentage of Democratic voters will change, or Democratic votes. So write the null and the alternate hypothesis for the setting. Is this a one-sided to the right, one-sided to the left, or a two-sided alternate hypothesis? Okay. Well, let's see if we can get the null written here. Well, the null is that what? Nothing changed. So the percent that vote Democrat is the same, which is what? 50%, right? It was basically 50% in the previous poll, right? Let's go back and take a quick look at that. Make sure you agree with me on that. See, what did they say? They said in the current previous poll, the current standing is that it was 50%, okay? All right, so what about now? Well, they're hoping that their candidate does better, but they're not sure. He could tank. In other words, the media really doesn't know. They just think that maybe it's going to change. And so they're going to say that the percent that vote Democrat changes. Okay? In other words, it's not 50%. Don't know what it is, but it's not 50%. Okay? So notice in this particular case, the situation that you've got now is that you're not sure whether it's going to go down or whether it's going to go up. It could be one of two possible cases, right? So if we were to go ahead and do our little number line trick again here, if this was the value of the null, which we currently say is what? At 50%, right? This time we actually got a number we can put on here. Then we think the alternate is going to do one of two things. Either the alternate could go up. That's one possibility. So we'll call that alternate, say, 1. Okay? And in this case, let's say that it went up to, I don't know, we'll just make a number here, say 75%. No particular reason, just picking a value to kind of get the idea here. Well, it could be that maybe the Democratic candidate does horrible in the ads and the debate and all that, and maybe his numbers tank, and maybe he goes down to 41% or something like that. Okay, so we're not sure which way his percentage is going to go, but we suspect in the alternate that it is going to change. So when this happens, this is referred to as a two-sided test, or a two-sided direction of extreme. Okay, well, hopefully that makes some sense and you're kind of getting the idea here. Definitely stay up with the reading. It's going to make this stuff a lot easier.